AMD-first LLM inference push. Open-weight models meet AMD-first engineering. OpenAI's GPT-OSS 20B and 120B landed with immediate support across popular stacks, but one team went much further. GPT-OSS AMB, a pure C++ HIP implementation that avoids rock-blast HIP blasts, RCCL MPI, and optimizes everything from flash attention to matrix core gem, multi-streaming, and MoE routing. On a single node with 8 times MI250s, they report 30K tokens sec on 20B and nearly 10K on 120B in custom benchmarks. Evidence AMD hardware can compete on large-scale inference when software is tuned end-to-end. Caveat: current kernels depend on AMD matrix cores, MI250 and similar. There's a legacy path for older GPUs, e.g. MI50, without matrix cores, but it runs slower. Consumer cards like 7900 XTX may handle 20B, but likely not 120B in full precision. The code aims for Llama 2.c style readability, and users report interest in quantized paths and API layers next. The timing aligns with AMD's larger AI tailwinds. Bloomberg notes OpenAI agreed to buy tens of billions of dollars of AMD chips. AMD's stock jumped as investors priced in the partnership's scale. If AMD's supply comes online as promised, a broader ROCm software push could follow. Exactly what frustrated practitioners ask for when trying to run mixed fleets across MI100, MI250, and RDNA cards. Serving tactics matter as much as silicon. Dynamic batching layers like Batchy show how to cap latency while packing requests over Unix TCP, isolating invalid jobs so they don't poison a whole batch. It's a proof of concept rather than production, but the pattern is what you want for bursty traffic and batch inference economics. And the cost math is still it depends. For bursty, intermittent usage, serverless APIs often win. For steady, high-throughput workloads, provisioned hardware plus an engine like VLLM tends to be cheaper. Frequency thresholds in the every 30 to 60 seconds range are one team's rule of thumb for when to switch. Model support is steadily normalizing. GPT-OSS runs across VLLM and SG-Lang. Meituan's long-cap flash chat ships deploy adapters for both. Llama.cpp remains the fallback on integrated GPUs. The momentum is toward engines that can exploit AMD's matrix cores when available, degrade gracefully when not, and still deliver decent context and throughput. Tiny models, big retrieval gains. Small can be surprisingly strong, especially for retrieval. NewML's Colbert Nano series shrinks late interaction retrieval into sub-1M parameter models. Trust 250K, 450K, 950K. By generating multi-vector embeddings, they enable CPU-only or on-device search with limited compute and can be specialized easily using datasets like FineWeb. They're not chasing leaderboard soda like BGE. They're targeting accuracy per watt and deployability. They integrate with TXTie via trust remote code and fit edge scenarios where bandwidth, latency, or privacy constrain heavier models. On the generation side, Liquid AI's LFM28BA1B uses a hybrid MoE with 8.3 total and just 1.5 beat active parameters to deliver speed on phones, tablets, and laptops once quantized. Architecture mixes 18 short-range convolution blocks with 6 attention blocks, long context, 32K, and BF16/FP8 training. The authors recommend fine-tuning for narrow use cases, agentic tasks, RAG, extraction, creative writing, while cautioning against knowledge or code-heavy tasks. Benchmarks show instruction following and math competitive with larger dense peers, and the repo includes HF transformers, VLLM, and Llama.cpp instructions. The broader lesson from practitioners: tiny specialized models are underrated. For tightly scoped tasks, a 1M parameter retriever or 1.5B active MoE can beat a 70B generalist by being close to the data and cheap enough to deploy everywhere. The trick is disciplined scoping and evaluation against the actual job, not generic leaderboards. MCP apps reshape enterprise workflows. Apps are moving into the model, not the other way around. A widely shared analysis argues OpenAI is turning ChatGPT into an OS-like distribution channel. An app's SDK built on the Model Context Protocol, MCP, makes apps first-class citizens inside ChatGPT, with secure connections to external data APIs, a pilot app store, and enterprise integrations, e.g. Spotify, Zillow. The piece claims 800 mem weekly active users and frames the core question for banks. Will AI live inside the bank, or will the bank live inside the AI? The same architecture could power internal copilots, compliance, audit, HR, through MCP servers. Risks include misconfigured MCP servers leaking data, platform control over app visibility, and explainability of decisions. Hands-on tooling is catching up. Claude Flow's v2.5 Alpha but 141 adds MCP tool integration, an in-process MCP server, a checkpoint state manager with create, list, restore, delete via CLI, and a hook system for automating Bash and Git workflows, useful for workflow recovery, reproducibility, and building robust assistance. On the ground, teams are still kicking the tires. One discussion asks for real-world agentic AI office workflows, automation, document handling, task management, and the responses reflect early exploration. Another thread shows why gluing systems via APIs matters more than copy-pasting. The right answer to how to automate Claude in the loop is call the Claude API or the Agents SDK, though budget concerns nudge some toward cheaper models and minimal usage. Be wary of low-signal content. The 11 AI agent projects post was removed as self-promo. Model-wise, Meituan's Longcat Flash Chat is explicitly tuned for agentic tasks. It's a 560B parameter MOE, but dynamically activates 18.6 to 31.3B parameters, 27B on average, uses a shortcut-connected MOE design to overlap compute and communication, and reports over 100 tokens sec throughput. The team outlines stability measures for massive training, a data curriculum for reasoning coding, 128K context, and multi-agent synthesis for post-training. Adapters exist for SGLang and VLLM, making it deployable in the same stacks teams already use for GPT-OSS. Reliability beats lucky seeds. A useful challenge to benchmark habits. Reporting pass at n without pass all n hides instability. For coding tasks like StutWe, what matters to an agent user is, does it work every time? Not, did it sometimes work across 5 seeds? Evaluations on StutWe Rebench show pass all 5 is consistently lower than mean resolved rate, and the gap varies by model, exactly the reliability signal teams need. Keep pass at n, but add pass all n to standardize reliability reporting for agentic use. Model scorecards increasingly include agentic and coding tasks, but interpreting them through reliability helps. Longcat Flash reports competitive results across bench verified, live code bench, MBPP+, and tool use benchmarks. These numbers are informative, but stability across runs is what operational teams should demand, especially when plugging models into CI/CD or automated remediation pipelines. Engineering choices can help models help you. Developers report better AI coding outcomes with modular architectures that keep files under 1K lines and isolate responsibilities, e.g., MVVM, reducing the context needed for a safe code increment. Frameworks like BMAT and SpecKit are cited as helpful scaffolding. The meta lesson: structure your codebase for small, precise edits, and your AI assistant will reward you with fewer regressions. Also new on the radar, ServiceNow AI's April 1.5 15B Thinker model card on Hugging Face and Basekick Labs ARC repository on GitHub, both worth a look as the toolbox for building reliable agents keeps expanding. Small poisons, big risks. A joint Anthropic, UK AI Security Institute, and Alan Turing Institute study finds that a small, fixed number of poisoned documents can reliably implant a backdoor during pre-training, independent of model size or total training volume. In their setup, as few as 250 poisoned samples suffice to cause a denial of service backdoor that outputs gibberish on a trigger phrase across 0.6B to 13B parameter models. The key takeaway challenges a common assumption. Attack success scales with absolute count, not percentage of the corpus, implying practicality even as datasets grow. While the studied behavior is low stakes, the mechanism raises the urgency of scalable defenses and data governance. Security lapses aren't confined to model data. Ruby Central's post-incident review of a September 2025 event documents AWS root-level account access tied to unrevoked shared credentials. Although no production harm was found and control was re-established via MFA and password reset, the episode underscores the need for tight credential lifecycle management, clear ownership, and transparent incident handling, especially for critical package infrastructure. These themes converge in the new MCP world. The banking editorial flags risks of poorly configured MCP servers leaking secrets, opaque AI decisioning, and platform distribution power. In short, treat data pipelines, credentials, and app connectors as part of your model attack surface, not peripheral plumbing. Few-step video generation arrives. NVLab's RCM pushes diffusion distillation to scale, delivering 2 to 4-step video generation that preserves both quality and diversity, even when distilled from 10B plus teacher models. The team introduces a score-regularized continuous time consistency framework, identifies SCM's quality bottleneck, and overcomes it via a forward-reverse divergence joint distillation. They open-source a Flash Attention 2 Jacobian vector product kernel with FSDP checkpoint parallel support and show results on WAN 2.1 T2V, 1.3B, and 14B. Remaining gaps, like physical consistency, are flagged as targets for reward-based post-training. The direction is clear: drastically fewer steps for real-time video generation without collapsing diversity. Your light bulbs are sensors now. Smart home ecosystems are turning existing radios into room-scale motion detectors. Philips Hue's Motion Aware uses Zigbee link fluctuations, signal strength, latency, bit error rates between multiple bulbs, and the new Hue Bridge Pro to infer motion via on-bridge AI. No camera, no PIR, just RF sensing. Setup includes an empty room calibration and works whether lights are on or off. Recommended spacing is 1 to 7 meters across 3 to 4 bulbs, but reflections can cause cross-room detections that require tuning. The bridge upgrade is framed as necessary for on-prem processing, though the monetization angle is fair to ask about. Underlying IP comes from Avani's Sensify. Qualcomm holds similar patents. Wiz beat Hue to market in 2022 with SpaceSense using Wi-Fi instead of Zigbee and works with as few as 2 devices. The broader pattern is ambient AI that leverages radios you already own for presence and automation. Lights on when you enter, HVAC off when unoccupied, without adding hardware or cameras. As always, calibrate carefully and mind the privacy trade-offs.